Hi, this is Julian from Endoxa. In this training lesson, we're going to look at how truth, falsity, and conflict are represented in Endoxa. This is a statement. Statements are the building blocks of Endoxa. A statement is just a sentence that can be true or false. The truth value of a statement can be chosen in Endoxa on a 10-point scale from true to false. The colour of the boundary of the statement box represents the truth value, from deep blue for certainly true to deep red for certainly false, with every value in between. These two statements mean the same thing in Endoxa. Saying that Britain is a well-run country is false is the same as saying that Britain is not a well-run country. But in Endoxa, we prefer the first statement to the second. We avoid writing negative sentences such as Britain is not a well-run country. Instead, the positively worded statement is made false. This halves the number of statements we need in the system. There are two truth values associated with each statement. One is assigned by the user. When you edit an argument graph, you can set this value. The other is calculated by the system using the logic of the argument graph. If there are no argument steps that have the statement as their conclusion, so if there are no incoming arrows, both values are the same. In this case, for this statement, both values are likely true, and the statement border is a pale blue colour. But if there is an incoming argument, it affects the calculated truth value. A pro-argument with a blue arrow, such as this one, makes its conclusion statement more true. The calculated truth value is represented by the colour of the outside of the boundary, the user's truth value by the inside. In this case, the outside is a slightly darker blue than the inside because the calculated truth value is highly likely true, and the user's truth value is still likely true. In this example, it's hard to see the difference. In this case, it's easier to see the difference. The con argument, with the red arrow, makes the calculated truth value certainly false, which is deep red colour. The user's truth value is still likely true, so pale blue. And it's easy to see the difference here. When the two truth values are far apart, as in this case, the statement is in conflict and it's greyed out. Conflict means that the user's argument is incoherent. The argument step makes the conclusion statement certainly false, but the user believes it is likely true. The user either has to change the truth value for this statement or find some way of defeating the argument step. Multiple argument steps can have the same statement as their conclusion. In this case, one argument step is pro and the other is con. This is called a rebuttal. The system works out the calculated truth value in the background. It depends on the strength of the argument steps, represented by the purple bars, and what argument type they are. If the conclusion is still conflicted, there are several options for the user to resolve this. For example, one of the arguments can be defeated by an evidence statement. In this case, this new statement defeats the con argument step, and the conclusion statement is no longer conflicted, so it's no longer grayed out. If all incoming arguments are defeated, then the statement reverts to the user's truth value. It's as if the incoming arguments didn't exist. In this case, we have another evidence statement that defeats this pro argument. With both arguments defeated, we see there's no purple bar left here. This statement has reverted to its original user-assigned truth value. Endoxa allows the user to decide what degree of belief to give any statement in the argument graph by assigning its truth value. It then keeps track of all the calculations to work out any conflicts. The user then has to decide how to relieve any conflicts if they arise. An argument graph with no conflicts is a coherent argument. This is the end of the lesson. Thank you for listening.